What do you have for W2? W2 8. Okay, I think you did a lot of approximation. It's close to 8. So maybe if approximate, you can almost get that if you it's close to that. It's like approximately 8. 7.8. Okay. Okay, so the area of fill or cut, anybody? 1.27 meters squared. Yeah. So that's it for this. Okay, that's basically it. There are several ways of calculating the volume. I've already talked about it. We have volume by mean areas. Mean means average. Okay, so the average of 3 things is just a sum of the 3 things by 3. Are you okay? Then you need to finally multiply. So you work out the areas, find and then find the average of areas. Are you okay? You can have volumes by end areas. Are you okay? Okay, so let me write the formulas down for us. Mean areas, end areas. Then we just close it. You don't take a break. I've seen that when we do these lectures, you don't take a break. That's very nice. Is that what? I seriously. Okay, so please take note that volumes are based on areas. So volumes by mean areas is V equal to A1 plus A2 plus A3 dot A n minus 1 plus AN all divided by N times L. Okay. So you are finding the average and you are simply multiplying by the length of the project. Cross section through the project, average it, multiply by how long it is, you get a volume. That's all. Then we have volumes by end areas. V is equal to D end, as you say end. So one end is A, has an area of A1, the other end is A2 divided by 2. So D is the distance of the cross sections. So the cross sections are D, a distance of D apart. Okay, cross sections. I should have been a medical doctor. I love my handwriting. Cross sections, D apart. Okay, and areas divided by 2. Is this very accurate? It may not be. Okay, but let's move on. Literally, you can do this one if you want to, extend it. I will be extended. Let's move on. We are going to fry, isn't it? Okay, let's do one volume calculation. It's all right. At least we say we done one volume calculation. It's all right. Okay, an embankment is formed on a ground which is level traverse slope. Embankment by falling at 1 in 20 longitudinally. You're not in the mood, eh? So that 3 sections 20 meters apart have center lines of 6.0. Okay, an embankment. So the keywords are embankment, level, traverse, level, traverse. What's a traverse? Traverse. So this English language, you traverse to the embankment. But falling 1 in 20 longitudinally. So what is traverse? What's the word, English word traverse? What does it say? I mean, should an engineer know some English or doesn't matter? It's just calculations. So it's falling 120 longitudinally. What does it mean? Okay, let's move on. So that 3 sections 20 meters apart. So we have 3 sections 20 meters apart, have center lines of 6 meters, 7.60 meters, 9.20 meters. Okay. All right. Respectively above original ground. So this above the ground. Are you okay? Embankments above the ground. Each. All right. That's what we are saying. Right. But there are different heights. So it's going up at some place, going down. Are you okay? So it's looking more like so. But every single point we have a certain cross section. Are you getting that? So when it reaches here, it does something like that. Then it slopes again. Again, so the 6, 7. So the height goes up. Again, the H goes up. So it's like as if we are describing the topography with these values. If the side slopes of 1 in 1, so side slope 1:1 are used. What's that? M, isn't it? Equal to 1, right? Determine the volume of fill between the outer sections when the formation width is. So formation width. What does this English mean? Determine the volume of fill between the outer sections. What does it mean? Anybody here who really kind of speaks English like they really know English? What does it mean? It's a very confusing statement. All he's saying is that when you have these are the outer sections. Are you getting that? These are outer. So between the outer sections, are you okay? No, means you have a middle section. Do you get it? We are not talking about the sides. Like so, we are really talking about this one. There are about 3 of them. So the one in the middle, then the other 2. Okay, so determine the volume of fill between the outer sections. What does it mean? It means find the volume defined by 3 different sections, in which you have 3 different H's. And so you're going to apply the formula to this 7 and 9. Is that also? All right, using the trapezoidal rule. Okay, doesn't matter. So let's just carry on. Area, what's the area formula, we wrote it down. H is equal to, no, area equal to H over B plus MH, isn't it? All right, so area 1, area 2, area 3. Yeah, we'll have different H's, but same M's, right? B's, we didn't specify specific B's. What was the B? Is that a B? Is that formation width? Formation width, not side width. Is there a formation width in this? It's what? 20. Okay. We'll find out. So let's take the first one. 3 sections 20 meters apart. What does that mean? That's looking more like the D, isn't it? And this formula, H here, what is it in this formula? 6, 7, that. B, what is B? Okay, let's go over the question again. An embankment is formed on the ground, which is level traverse to the embankment are falling at 1 in 20. Okay, continually, so that 3 sections 20 meters apart have center line height of 6, 7, yeah, and then 9.2 meters respectively. Okay, above original level. If the side slopes of 1 in 1, that gives us the M I use, determine the volume. So what is B in this case? Why is it 20? 20 is sections apart. So if you want to work out volume, okay, of something looking like this, okay, how many sections do we have? We have 1, 2, 3. Are you okay? If it's an embankment, the center line goes through like that. But then the H's are actually here, different H's. So that's the 6, 7, 9.2. Okay? All right. So look at this line here. I think you're all sleeping. What is that? Say, read that. Formation is what? So that's supposed to be the B, isn't it? So were you writing it? Have you been writing it? That means you are tired. You are not flowing. Are you okay? So that's the formation width. So you should have said, oh, sir, you didn't complete this statement. And because of that, we don't have the B. I get that. So it's 6. Formation width is 6 meters. So now we have the B. Right? So I think you're all tired. So if you plug it in, yeah, it means you're not even flowing at all. So once you put in these values, different H's, we'll be having 3 different units. Now by the formula. Okay. So basically, that is that. We'll end it here. Okay. And then we continue another time. All right. Is that fine? Because I can see from this one that you're not following at all. I think we don't take a break. This would have been a nice time to take a break, but I'm thinking we just end it. It's 12 o'clock, right?
So where are you? So I'm here.
Hey, where are you coming from? Grace.
Is that
What are you saying?
someone also here? Nobody is worrying me. That's nobody is worrying me.
That's what was okay. We heard you. We are recording this for YouTube, so please don't say anymore. I put a video on YouTube and there was a comment. So I said, don't let the students come in like that. If someone was making some mistake. Guys, these are just formulas. Are you okay? Just put it in, work it out. All right. Once you have areas, put it into the formula, and then you are fine. Okay. I think we put down this that formula We can also have other formulas for the prismoidal formula. They are all just things that you can relate to. It's not complicated. So I want you to just take your time, sit down. You appreciate it from what we already talked about. Okay? If you have an issue, let me know. The last thing that we'll talk about, which we won't talk about because I'm thinking we should end it here, will be the mass Hall diagram. Are you okay? The mass Hall diagram, which is simply a graph of how much volume you are moving. Are you okay? Along in a longitudinal sense. Are you okay? So as if you have a project going all the way to Kaswa, and as you go, how much cut have you made? Are you okay? How much fill? So cumulatively, how much cut have I done? How much fill did I do? So by the time I get to a certain point, the value cumulatively can be 0. You get what I mean? Then I can start cutting again. But if I actually take a good job of just 15 minutes, then even though it becomes 0, so I cut this. How many minutes? Do you understand what I mean? So let's assume that I cut this amount. I fill, now I need more to fill together. So cumulatively, I'm having 0. Okay, what's really important in terms of mass for mass for okay. So you can just have a table. How much do I have to cut at the spoon? How much do I need to fill at the spoon? Are you okay? Okay. At this particular chaining, how much cut do I have? Do you think it's possible to determine? How do you do that? You use the formulas. You can say that, okay, from here to here, how much do I have? At any point, you are cutting or you are filling. So this one, I don't even know if it's even worth having a special lecture on it. It's that simple. Are you okay? It's that simple. So you do a plot of a cuts. It's like you actually tabulate the cuts in the fields. Are you okay? Tabulate them. Then you can relative amounts. Okay. So cuts become positive and then fills become negative. When I need to fill, it's like I'm owing. Are you okay? I need to borrow to fill. Are you okay? But I can use my own cut to fill. Are you okay? Like I said earlier, maybe the material may not be have to still borrow. Are you getting that? And then on and on. And that's it. So please sit down and do a lot of work. It's okay. On your own, and have groups, you can form groups, study groups, discuss, and everything will be just fine. If you have an issue on mass or that, let me know. Since I think we talk too much about something, it becomes complicated. Okay? So do you have an assignment somehow? The class ended, but I need to do more calculations on take a volume formula and then put it in and see whether you lose. Okay? And then the mass or diagram, read about it. Okay? But I've just summarized it for you. That is basically it. We need to also consider the volume after compaction. Okay? The volume before compaction. Are you paying attention to it? The volume before compaction, volume after, which one is bigger for most materials?
Volume.
The volume before compaction, volume after compaction. After compaction, what happens to the volume?
Volume.
Say again. So let's assume that this amount is to fill this and we are saying that it wants this will not fill the same volume. Why? Because it shrinks. Every material shrinks after compaction, isn't it? What about when we cut? Do we have a same volume? So if I need 100 cubic meters to fill this, and I take 100 cubic meters, is it correct to do that?
No, sir.
Okay, so there should be a factor, shrinkage factor. Are you okay? That the 100 will probably shrink by a certain percentage, which I should now add into my calculation. Are you okay? So that I can now probably take 120 meter. Are you okay? Compact it, and it will compact by a certain factor. Are you okay? To reduce by a certain factor. Then I'll get my number. So we need to consider that every material, so depending on the material, if you have a rock and you have sand, which one of them do you think will reduce in terms of volume? I mean, per your own intuition.
Son.
Sand will reduce more than, isn't it? So depending on the material, there's a certain shrinkage factor. Are you okay? And then, yeah, so please, guys, that's it. We have two because I'm included, 2 people.
Let's say
Gabriella and Christopher.
this bright age.
Is Bright online? I can't see
The
him.
road is like
Say again. He's hiding. He wrote his name now. He's not. I haven't seen him. Okay. So, all the best, guys. And see you again next week. Okay?
Thank you, sir. So we'll see you next week. Face to
Yes,
face.
next week we talk about remote sensing. I don't know what we're going to be talking about. We talk about horizontal control, but we won't be calculating. That's what I'm saying. I won't be doing like formulas like that. Is that fine?
no, sir.
Okay. All right.